What? Have signs of life been discovered on Mars again? On September 10, 2025, NASA held a press conference. Acting Administrator Sean Duffy boldly announced that they had found potential signs of life on Mars, and this time, it's the most reliable signal yet. Finding extraterrestrial life is somewhat like the tale of the boy who cried wolf. Not long ago, when signs of life were detected on exoplanet K2-18b, it was also hailed as the strongest evidence to date, but in the end it wasn't conclusive. So, is this discovery of signs of life on Mars just another false alarm? Actually, the discovery of signs of life on Mars alone has happened more than once or twice already. After all, Mars isn't too far from Earth. In 1877, astronomers observed gullies on the surface of Mars through telescopes for the first time. News of canals on Mars quickly spread. Later, the concept of Martians appeared in many science fiction works. In recent years, polycyclic aromatic hydrocarbons have been found in Martian meteorites, methane gas has been detected in the Martian atmosphere, and organic molecules have been discovered in Martian rocks. The question of whether life might exist or once existed on Mars has never ceased to be discussed. In July 2024, the Perseverance rover was navigating the edge of an ancient river valley in Jezero Crater. Its current mission is to investigate a Martian layer known as Bright Angel. Initial explorations have shown that the sedimentary rocks in this layer are composed of clay and silt. Therefore, if life really did exist on Mars, these sedimentary layers formed by lakes or rivers are the most likely places to leave traces. Perseverance has chosen a red rock named Cheawa Falls, which is about 1 meter long and 0.6 meters wide. It features colorful spots resembling leopard print. Instrument analysis showed that, in addition to containing organic carbon, this area also contains two special mineral components, vivianite and greigite. These minerals are commonly found in sedimentary rocks, peat bogs, and around decaying organic matter on Earth. Many microorganisms that consume organic matter derive energy through iron reduction and sulfate reduction reactions, eventually precipitating these minerals. In other words, this time we have discovered not only organic matter on Mars, but also associated minerals. Compared to a simple material discovery, this geological context alignment serves as a powerful cross-verification. However, the old question remains, can't these chemical reactions be explained by non-biological processes? Of course. For instance, vivianite can indeed form through ordinary chemical reactions under specific conditions, without the involvement of life. Pyrite is even simpler. It can form when sulfur-rich magma cools and crystallizes, and some organic matter can directly reduce iron oxides under certain conditions. However, the key issue is that these conditions often require relatively high temperatures. The minerals on this rock should not have experienced high temperatures. They resemble Earth's low-temperature environments. Under normal low-temperature conditions, without biological processes, the rate of related chemical reactions is extremely slow, making it impossible to naturally produce so many minerals. This is why NASA researchers believe that, although non-biological origins cannot be completely ruled out, the possibility of biological processes is greater given the current situation. Therefore, researchers consider it a potential biosignature. Now you understand why NASA claims this signal is the strongest so far, right? Because this discovery is not just about finding a single organic compound or a metabolic product of life, but a complex chain of evidence. However, even with a relatively complete chain of evidence, we still cannot assert that life definitely existed on Mars. Firstly, the analysis of the rock composition is currently done on the rover. No matter how advanced the rover's equipment is, it can never compare to laboratory equipment. Secondly, after all, Mars is not Earth. There may be some geological processes on Mars that humans have yet to understand, and these unknown geological processes might also be able to form unique patterns like leopard spots under low-temperature conditions. So the current task is to find a way to bring the samples back for more detailed analysis with Earth's laboratory equipment. Perseverance has already collected many rock samples, including this one. They have been stored in containers, waiting to be sent back to Earth someday. However, the plan to bring Mars samples back to Earth doesn't seem to be going smoothly. Due to well-known reasons, NASA's research budget is facing significant cuts. But the good news is that China is also advancing a Mars sample return mission, the Tianwen-3 Mars Exploration Mission. In June 2025, an article published in Nature Astronomy systematically outlined the scientific blueprint of the Tianwen-3 Mars Exploration Mission by scientists from the Chinese Academy of Sciences and the Tianwen-3 project team. According to the Mars landing window, Tianwen-3 is expected to launch in 2028 and collect at least 500 grams of samples and return to Earth by 2031. Although 3 years is very tight and Mars sample return is a first attempt, fortunately the relevant core technologies have been validated to some extent on Chang'e 5, Chang'e 6, and Tianwen 1. So you could say there are some issues, but they're not serious. If the sample issue is resolved, how should we tackle the problem of unknown geological activities? Indeed, strictly speaking, this seems to be an unsolvable problem. After all, no matter how much you verify, I can always argue that there might be undiscovered situations. Therefore, this issue can only be approached like particle physics, by maximizing the confidence level. When the confidence level is sufficiently high, we can consider that extraterrestrial life has been discovered. In 2018, an astrobiologist in Lhasa proposed a reference standard for a life detection confidence scale, which includes 7 levels. Level 1. A suspicious signal is detected, but its origin is unknown, and it might even be contaminated by humans. Level 2. The possibility of signal contamination is eliminated, ensuring the signal's authenticity. Level 3. It is confirmed that the signal can indeed be produced by biological processes in that environment, rather than by random natural phenomena. Level 4. All possibilities of non-biological processes causing the signal have been ruled out. Level 5. Similar signals are found elsewhere, indicating an independent second signal is discovered. Level 6. The same results are obtained in multiple observations at different times, indicating it is not a coincidence. Level 7. Clear biomarkers are found, or the behavior of the life form itself is directly observed. Only upon reaching this level can the discovery of extraterrestrial life be considered thoroughly confirmed. It is evident that previous reports of discovering signs of extraterrestrial life, including the recent discovery on Martian rocks, mostly linger within the first 4 levels. Even if Mars samples are brought back to Earth in the future and the possibility of non-biological processes is further ruled out, the confidence level would only reach the 4th level. Subsequently, besides searching for similar results at other times and places, the most crucial task is to find clear biomarkers that prove the existence of life. From a scientific perspective, although this discovery is significant, there is still a long way to go before we can finally confirm the existence of life on Mars.